Okay, we had some technical difficulties. I apologize. I really apologize for this. Um, oops. Okay. I apologize. I really apologize. For some reason, it just stopped. It just stopped. Maybe why? Why? Maybe because I'm also recording locally. What if I shut this off? And I only stream and then I download the video later on. Yeah, let's do it like this. Welcome back. Welcome back. There's someone here. Welcome back. So, okay, I have X and Y. I have the two input vectors here, input features, like as I said, time spent and I don't know, amount of coffee drank to get points on an exam. Okay, I think I have already lin reg is what? Linear regression. I already have it. Lin reg. Let's fit it on X and Y. Coefficients. No idea if this is correct. So let me print out coefficients. Mm-hmm, 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 mm-hmm. Okay. So I have coefficients. If I run this, okay, these are the coefficients. And now if I print the intercept, these are basically the solutions to linear equations. Interception. Wait, let me just make sure if the stream is still running. Yeah, it is. Okay, welcome back. Hopefully it will work now. Hopefully it won't be jittery and broken. Yeah, this messed my whole conception now. But all right. So if I print this again, I have the solutions to this, to this, to this list of linear equations. I've been given weights for each feature and the bias, which is the y-intercept. And it prints, let's say, 2, 1.5, and 2 here. So our model in this case, because it print out this, is going to be 2 is 2 times x1 plus 1 0.5 times x2 plus 1.95 or 2. I also misspelled intercept, doesn't care. Okay, but now I need to fit ridge regression, and this time I need to fit it with regularization. So here I'm actually importing all of this, but let me just copy this. This is a test snippet, so it's not from the book, it's something that I've been doing. Okay, I'm gonna copy this here. I'm gonna put the alpha to be, I don't know, 1.0. And then I'm gonna fit this on the ridge regression. And what now? What if I, instead of the linear regression here, I use ridge reg? Okay. Hi, we have, oh, we have 2 people now. Yeah, sorry, we had some technical difficulties if you came from the old stream. I'm basically trying to, the way how I learn best, personally, is to do a bare bones example of the problem, simplify it. Like here, I have this X matrix and Y, the list of solutions, and I'm trying to do this step by step. Okay, so coefficients, intercept, what's the difference here? And what happened here? So ridge did something behind the scenes. It shrank the weights to make the model simpler and more stable, which will be less likely to overfit. And let's say we have a new input. X new is gonna be numpy array, what I will have, 2 and 4. And now if I print linear prediction, it's gonna be linear regression, predict me X new, and I'm gonna do the same for ridge. Hey, ridge. Sorry, the old stream just collapsed on itself. I don't know what was going on. If you just joined, what I'm trying to do, I'm a software engineer. I realize that the machines are taking over, so I'm learning all of this machine learning crap in order to be a good slave to them. And right now, apologize, I drank some water. Right now, I'm at a point of being totally mocked by by ridge regression predictions or whatever this is. I'm doing a really simple example of it. What happened now? Where the hell? What happened? Ah, okay, I collapsed it. So if I run this again, hey Faisal, welcome. I love your avatar. Yeah, NumPy is fun. I had to I spent like 2 weeks like deprogramming my brain from thinking of regular arrays when seeing these. I had to slap myself on the face. Okay, these are matrices, these are not. Okay, Yeah, the Giga Chad. Okay. So the ridge prediction just gives, oh man, it just gives us the same crap. It just um so the linear regression tries to fit the best line, but ridge regression is 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 trying, okay, to say, okay, don't go wild with whatever numbers we have here. Do I want to plot this or to go with a real example, or maybe to okay, let's go further. So I'm gonna comment all of this, and here I'm running the ridge. Where is it? Here I'm running the ridge regression again, but on real data. Okay, what if I go above? X has one feature, but ridge is expecting two features as an input. Okay. So I fit these values for X and Y, and then it predicted a new value, which will be 1.55. And this, I think, will just draw the, yeah. So what's going on here? What's going on here? Okay, I create a plot. I create a subplot. I'm plotting what is the ridge. What the fuck is the ridge? Plot model ridge. Okay, but where do you pull the ridge from, brother? Plot model. Okay. This is the class of the model. I completely missed this whole fat method right here. Okay, so this will just generate a plot showing the effect of ridge regularization. Okay. So we'll have linear regression, we'll also have polynomial regression as an example. So, okay, this just generates the plot. This is a wide figure. We have the left plot. Here I'm creating the plot using the plot model. I'm gonna go back to the method to maybe go over it as well. Okay, Y label, this is the right plot. I'm using the same thing. Okay, here I'm providing the alphas. What's this one doing? Axis, Y-axis, set tick labels. No idea. I think it's just a configuration. Step for plots. I don't think this is important, but okay, it just creates these two figures here. What are you doing, you big fat asshole? What are you doing here? Okay, I'm plotting X, Y, blue dots. Okay, it's using blue dots. Line width 3. Okay. So these are my points here. All of these blue dots right here. If alpha style in zip okay, so it's pulling this. What is zip? Is this a method? Zip object yields n length tubes. Ah, okay. So this most probably, because we provide the alphas here, it's a tuple of 3 elements. This is also a tuple of 3 elements, so it's gonna pick each one. So alpha of 0 will have blue. Is this blue, green, and red? Yeah. So alpha of 0, and you can see here in the legend. So we are just iterating through this, and the first one is gonna be 0 with blue dot line, then we'll have green line then we have just a regular line here, and the alphas will match to every one of these. Okay, if alpha is greater than 0, no, I don't. If alpha is greater than 0, I have a model here. And I'm an idiot. Okay, if alpha is greater than 0, I'm using the model class that I'm provided. Actually, I'm using ridge. I'm creating the alpha, I'm creating the arguments. Otherwise, let's just do linear regression. Plot model, how many times have I called this? Only 2. Otherwise, let's do linear regression. If there's a polynomial, like I provided it here, let's create a pipeline with the polynomial features of degrees. Standard scalar, I don't know what standard. Then we fit the model, and then we predict with the where is 6 new? Where? Then we predict the value. Where is 6 new? It's here somewhere. Where has this come from? X underscore new. I thought. Okay, so this is just a method that iterates through all of these options, checks if alpha is greater than 0, does some logic. If we provide a polynomial, we create a polynomial pipeline. We fit the model on x and y. We predict the model on the new value, but I have no idea where this new value is. It's here somewhere. It must be here somewhere. Where is this created? X new. All the way. Ah, here. Okay. So I'm predicting when I'm multiple values. I'm predicting the new y. I'm plotting all of this. These are just configurations. Model class. Am I using the model class again? No. So these are the points, the blue dots. The blue line. The blue line is the alpha of 0. Plot model. The blue line is the alpha of 0, and if alpha is greater than 0, because it's not, I'm creating a linear regression here. Okay, so I'm creating a linear regression, which I assume is the blue line. Now the green line is 10. So alpha is greater than 0. We are calling our ridge class right here. This is the green class. We have the alpha of 100. This one is a bit broken or not okay. So blue, green is a bit more conservative. The same thing here with the polynomials as well. If the alpha is 0, we are calling it linear regression, but I also provided a polynomial flag as well. So I'm using linear regression, but I have these pipeline steps here to take care of. So this is the blue one. The green one is a bit more conservative. And the red one, again, is just broken. Wow. I actually somewhat think I got this. What about you guys? I think I'm getting this because as we increase alpha, again, I have no idea what alpha is. Alpha is a black box in my mind. As we increase alpha, we are getting a more flatter line. Okay, the book also says as with linear regression, we can perform a ridge regression either by computing a closed form equation or performing gradient descent. So this is a gradient. This is the same thing, only using gradient descent. The same thing as above. It does everything the same. Has it predicted the same value? 5532 5530. Okay. Yeah, we use the gradient descent here. Oh man, you know what's the worst thing? I spent, I think, another hour learning about gradient descents in this exact chapter, and still now I came across them, and it took a minute for me to like, oh, what the fuck is, oops, what the hell is a gradient descent? It's important to constantly no, retrain is not the right word. If you are learning a concept, I think it's really important to keep those memorization cards, and these things I found ridiculous back in the time, but it happens. Okay, so the book mentions gradient descent, and I man, I have no idea what's happening here. What else, man? What are you doing? Slow shows the closed form solution of ridge regression compared with the net. Okay, okay. Ridge regression, I think I got it. I think I got it. But I want to do a real example. Something simple now. I have a calmful voice. Thanks, man. Thank you. Thank you. I um what kind of app are you building? Software as a service? What kind of, I mean, if you can speak about it. And regarding my voice, I always thought that people don't like my voice or don't like hearing me. But this is the only way I can study, like by talking to myself. And I realize why not stream it as well? Okay, okay. This is the ridge regression. Let's do another example. Like a really simple one. I think the book over explains this this bullshit. I think they really went above and beyond in order to confuse you as much as they can. I really have a problem with textbooks, and I realize that now. And I know there's a great little point where this vastness of textbooks and comprehensiveness of textbooks meet with the basic stuff you find on Udemy. Man, that sounds really cool. Series which can be easily done through AI, ML, like data visualization of Earth surface data. So what are you doing, like certifications or something like that? Like these, when they draw mountains, like you have the outer layers being different color, and as you approach the summit, they're becoming more and more colored in a different way. Is it something like this? I don't know how it's called. I'm sorry. Okay, how to fit a model. Again, let's do the same thing here. I'm gonna do the smallest example here. MP array. Bum. Bum. 1. 2. 3. The same thing here. MP array. 2. 3. 5. Oh, is this okay? Why is this one wider than this? I have 3 R's here. Okay. So we don't have 2 features here. So the formula is only ax plus b. So I'm trying to find x. No, I have x. I'm trying to find a and b. Okay. Plane linear regression. Plane linear regression. Okay, what is the goal of plane linear regression? Is to minimize what? The error. So it wants the smallest possible error using the MSI. Oops, using the MSI. And I have somewhere the formula for MSI here on my tablet. But actually, let's just find it online. MSI formula. It's the mean squared error. Yeah, and this is the formula for MSI. I'm going through the whole data set. I'm dividing this by the number of data points. And I'm subtracting my value from the predicted value. I'm squaring it. I'm dividing it by the number of data points. And this should be my mean squared error. And linear regression. No. Okay. Lin regression fit x, y. And now I'm printing the linear coefficients, lin reg coefficient, and I'm gonna do the same for interception. And by the way, coefficient and wait. Values. Let me just show you this, because this one, again, this is what I don't like about textbooks, because A is the interception, is the empty value. B is the coefficient. It's the value that is related to an unknown, and we can have multiple of these. Is there another image here? Is there another image here? No. So basically, when we are saying, oh, interception and coefficient, where is this? Oh, it's here. Interception and coefficient. I'm only asking for the values of A and B, and nothing else. So we are gonna have a model that will be 1.5x, because these are the coefficients. They could be multiple of them, plus 0.33. Okay. This is a linear regression. Now, a ridge regression uses a different cost function. Instead of MSI, it's gonna use a different one. Let's ignore the math for now. But basically, the formula for ridge is is it theta? I hope it's theta. It's MSI, so it's the formula we have plus alpha plus v squared. So alpha here is a value used in ridge regression. which is a context that multiplies the term controlling regularization strength. Basically, based on the alpha value, we can reduce the weights of our coast. I always have like 4 or 5 viewers and no one speaks. Maybe people just leave me up in the background, which I mean it's a compliment that people think I have a nice voice. Maybe I should start eating carrots on an ASMR channel or something like this. By the way, next time when you and the other 2 viewers don't have any work, I always wanted to teach people's, and I don't know. I would like to see if you can follow like what I'm trying to explain, the way I'm understanding it, and the way I'm teaching it to someone. Being a teacher is a really noble profession. Too bad teachers are really paid like incredibly shameful salaries, man. Okay. Okay, so what do I have here? I have my predictions. Let's say, wait. Lin, reg, no. How can I print the prediction of this? Ah, okay. So, wait. Where's my tablet? Maybe I can write this better. Okay. So I found the coefficient and interception. So it's 1.5x plus 0.33. And then based on the input of 1, 2, 3, which is the NumPy array, I get, if I plug this in for every one of these values, I'm gonna get a y predictions of what? 15183, 15 times 2, plus it's 3 plus 0 is 3.33, 3 times 1.5, it's 4.5 plus this, it's gonna be 4.83. But these are predicted values. Our true values are 2, 3, and 5. So we have our errors, and the errors are the values that we subtract from here. So the error will be minus, wait, okay. The errors will be minus, so I'm subtracting the predicted value, wait, I'm subtracting the predicted value from the real value. So it's gonna be minus 0.17, it's gonna be 0.33, and minus 0.17. Okay. Next, I can calculate mean squared error, and I'm calculating this by, I have 3 data points, so I'm dividing all of this by 3, and I'm multiplying this by this value squared, so it will be minus 0.17 squared. The other one is going to be 0.32 squared, and the third one is going to be again 0.17 squared. Oh, when it's all add and done, it's going to be 0.055. Okay, so this is the MSI, but then I also have the ridge cost, which is this value that we just produced here, plus 1 is the alpha, multiplied by 1.5 squared. 1.5 is the first solution that we got, and it's related to x. Sorry, and it's here, it's glued to x. So I'm gonna get a pretty big number here, I assume. 2.305. So if I provide alpha here, and if I provide a big alpha like 1, the cost of the ridge is bigger than the cost of MSI. But what if we decide what the best value is with regularization? Ridge. Okay, ridge reg. I'm just gonna copy this. I have no energy left in me. Ridge reg. It's gonna be a ridge. I need to provide a ridge. I need to provide alpha. Alpha is 1.0, and I'm fitting it against x and y. And now I'm gonna copy all of these coefficients here, and instead of linear, I'm gonna say ridge. Instead of linear edge, I'm gonna say ridge edge. Ridge edge. So I get a different value. So the ridge reduced, the ridge reduced the slope from 1.5 to 1, and it increased the intercept. And now I can draw both of these. X, range, numpy, line space 0, 400, reshape -1, 1. Okay, let me just get the predictions here for linear and for ridge. Let me just create the plot, scatter. Wait. Scatter. I'm just gonna copy this again, but instead of I'm gonna have plot here, and it will be the range, and it's gonna be linear solution. I'm not gonna have a color here. No. It's gonna be blue, and label is gonna be linear. And if I plot the other one, I'm gonna, why is it, where? Aha, I'm missing here a comma. I'm missing here a comma. I'm doing the same here, but instead of linear, I'm gonna use ridge, and it's gonna be red for the ridge, and the label is gonna be ridge. What if I run this now? Oh, this looks so simple, but yeah, basically we are just, oh man, when I said I wanted a simple example, this one is really simple. So it's just another way of solving linear regressions, but why is it better than linear? I think that's it. That's it. It was really underwhelming once we got away from all of this bullshit in the books. But we can use ridge regression when features are noisy and when we overfit easily. I think that's the main use case. Again, I'm a novice here, so I don't have the 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 experiential background in order to explain you why and when this would happen, and maybe proper examples in which they would happen. But basically what ridge does is just reduce overfitting. When we have many features, when the data is noisy, when we are doing polynomials, let's say. So yeah, what's this? This sounds interesting. Yeah, this looks really cool, but okay. What's the time for me right now? Ridge regression. Oh, this one is even worse. I apologize. I forgot to turn off my phone. This one is even worse. Maybe I'll do this for the next one. For the next video that is. What I want now. Ah shit, I have no time to do my video game stream. I'm gonna do it the next time. I really apologize, guys. It's relatively late where I'm from. I just wanna play some games and get early to bed because I'm working tomorrow. I don't thank you all for watching this video, and I hope you learned something. I hope also the sound of my voice in the background is calming enough for you. Thank you all, and see you in the next one. Bye.